In this video, I wanted to provide another example of how IV estimation can be used. So the example we have here is that we are trying to estimate the sort of effect which classroom size has on an individual's level of test scores. And the sort of theoretical effect that we might expect that classroom size has on an individual's level of test scores is that as the classroom size increases, that means that the teacher has to spend more time sort of policing the classroom and less time teaching. So the sort of level of teaching in larger classroom sizes happens to be lower. So because of that, we would expect that the sort of coefficient on classroom size is sort of less than 0, because as classroom size increases, test scores tend to decrease. But the problem here is that there are a whole range of sort of omitted factors which are contained within this sort of error term here, things like an individual's level of innate ability, their family background, which tend to be correlated with classroom size. So there's some sort of selection bias happening here. So we need an IV to provide some insight into the true sort of effect of classroom size on test scores. And the sort of work which we're going to be looking at here is that of Angrist and Lavie in 1999. And the particular instrument which they used here was derived from what is sort of known in Israel as the Maimonides rule. And the Maimonides rule, what it is it's a sort of rule which governs classroom size in Israeli schools. And the way in which it works is that the classroom size of a given class is equal to n, where n is the number of students which are enrolled in that grade, if n is less than or equal to 40 students. Whereas if the classroom size was greater than 40, then the classroom size is approximately n over 2. So this is when the number of students in that year is greater than 40. So you can sort of think about the two situations. If the number of students in a given grade or a given year was equal to 40, then the classroom size for those students would be just 40 students. Whereas if the number of students in that year was equal to 41, then the classroom size of the two separate classes would be 20 and 21 in theory. So because of that, you can see how this sort of variable n, the number of students enrolled in that grade, could affect classroom size. But also, not only does it affect classroom size, it's likely not particularly correlated with these sort of omitted factors, things like innate ability or a family's sort of background, or an individual's family background rather. So because of that, you can sort of see how this sort of variable n here could be used as an instrument for classroom size. So when Angrist and Lavie estimated the above relationship via OLS, they found that their estimate for beta was greater than or equal to 0. So that seems to suggest as classroom size increased, test scores tended to increase as well. And this doesn't seem to chime particularly well with the sort of theory which you might sort of intuitively think was going on here. So that seems to suggest that they needed to use an IV. And when they used this IV, which I've sort of indicated above, from the sort of Maimonides rule, or derived from the Maimonides rule, then they actually found that the effect of classroom size on test scores was less than 0. So this seems to suggest that the sort of OLS estimates here had considerably more sort of selection bias than that which was obtained via IV estimates. So the IV estimates in this particular example, in contrast to the previous example, showed considerable difference to those which were obtained via OLS.